What if I told you that one of the most brilliant, complex, and deadly shapeshifters on Earth isn't from some science fiction movie, but is actually completely microscopic? We are looking at a biological heist that has literally been perfected over millennia.
Think about this biological riddle for a second. How does a single microscopic organism manage to outsmart both a flying insect and the human immune system? It doesn't just survive, it thrives. And it does this by constantly changing its form, essentially mastering two completely different worlds.
To put the sheer scale of this invader's success into perspective, just look at this number: 229 million. That was the estimated number of people worldwide infected with this parasite in just one single year, 2019. We are talking about massive global stakes here, with nearly half of the entire world's population at risk.
But, this isn't just about massive abstract numbers. It's about real, vulnerable lives. In 2019, an estimated 409,000 people died from this infection. And tragically, 67% of those deaths were children under 5 years old. That literally means one child died every 2 minutes. This is exactly why understanding this complex life cycle matters so much.
The disease we're talking about, of course, is malaria. It's a life-threatening illness caused not by a virus and not by a bacteria, but by a microscopic protozoan parasite called Plasmodium. And to get into our bodies in the first place, it needs a delivery system.
So how does it actually get inside us? Well, it all kicks off with the female Anopheles mosquito. Now, she isn't malicious, she just needs a blood meal to nurture her eggs. She hunts between dusk and dawn, completely unaware that she's acting as a sort of taxi service for a biological invader, injecting it directly into the human bloodstream.
Here's where the shape-shifting really begins. The parasite enters the human body as a sporozoid. Think of these sporozoids as the initial, highly mobile invasion force. But they don't hang around in the blood for long. No, they have a very specific target in mind.
These sporozoites travel directly through your blood vessels straight to the liver. Once they arrive, they infect the liver cells, basically turning them into a hidden covert cloning facility. Inside this safe haven, they undergo a rapid multiplying process, reproducing asexually into thousands of copies, all while the human host doesn't feel a single symptom yet. It's completely silent.
After this quiet multiplication phase, boom, the factory bursts. The infected liver cells rupture, releasing a brand new shape, the merozoite. Imagine thousands upon thousands of parasite offspring, just a massive army, breaking out of the liver and flooding right back into the bloodstream, totally ready for the next phase of the attack.
And this is where the hostile takeover truly gets going. If you were to look under a microscope, you'd see normal, healthy red blood cells completely compromised by these invaders. The merozoites actively break right into our red blood cells, just to hide from our immune system and grab a free meal. Once they're inside, the parasite totally hijacks the red blood cell. It feeds, it grows, and it shapeshifts again, multiplying until the cell is literally stuffed full. Eventually, the red blood cell just can't hold them all anymore, and it bursts, releasing a massive new wave of parasites to infect even more cells. This explosive, continuous cycle of invading and bursting is exactly what causes the severe fever and intense chills that are the hallmark symptoms of malaria.
But here's the thing. This explosive cycle can't just go on forever, right? If the host gets too sick, the parasite goes down with the ship. It needs an exit strategy. So can you guess where the parasite hides next to pull off its great escape from the human body?
Actually, instead of multiplying, some of those merozoites make a really clever pivot. They change shape yet again, transforming into male and female gametocytes. These specialized forms don't cause illness directly. They act kind of like little escape artists, floating in the bloodstream, patiently waiting in the dark for their getaway car. And here comes the extraction. A second, uninfected mosquito comes along looking for a blood meal. As it feeds, it sucks up those male and female gametocytes. The whole battleground instantly shifts from the human bloodstream straight into the mosquito's gut. Here, triggered by the sudden drop in temperature, the gametocytes finally mature and the sexual cycle begins. Inside the mosquito's stomach, the male and female gametocytes fuse together to form an entirely new stage, the eukinete. The parasite is now actively using the mosquito's digestive tract as a breeding ground to create the next generation of invaders. This eukinete embeds itself right into the mosquito's stomach wall and develops further.
Eventually, it bursts to release thousands of brand new, highly motile sporozoites. These new sporozoites migrate straight up to the insect's salivary glands. And just like that, the trap is successfully reset. The very next time this mosquito bites a human, the whole cycle starts all over again.
So, stepping back from the microscopic view for a second and zooming out to a global public health level, we are faced with a pretty monumental question. How on earth do we stop a microscopic shapeshifter that has completely mastered survival in both a flying insect and the complex human body?
The strategy is all about breaking the cycle at its weakest links. To stop the mosquito vector, we use insecticide-treated nets, or ITNs, to provide a physical and chemical barrier while people sleep. We also use indoor residual spraying, applying insecticides to the walls inside houses. Now, over on the human side of things, we use rapid diagnostic tests to quickly find the hidden parasites, and anti-malarial drugs to clear them from the blood before they can ever be passed on to another mosquito.
When we apply these interventions effectively, we're aiming for two main goals. Elimination means stopping the local transmission of malaria in a specific geographic area, basically getting cases down to zero and keeping them there. Eradication, on the other hand, well, that's the holy grail. That is the permanent reduction of malaria to zero worldwide, meaning we'd never even need these interventions again. But nature always fights back. We face some massive hurdles here. Mosquitoes are actually evolving resistance to the insecticides we use on our nets and walls. And even worse, the Plasmodium parasites themselves are developing resistance to our vital anti-malarial medications. Combine that with fragile health systems and a lack of global funding, and progress can easily slip right away. As we've seen in this explainer, this microscopic enemy is unbelievably adaptive and resilient. From the silent invasion in the liver to the explosive battle in our blood and that stealthy escape via a mosquito's gut, it really is a masterpiece of biological survival. So I want to leave you with this to think about. If a single parasite can endlessly outsmart both a flying insect and the human immune system, what incredible innovations and global teamwork will it truly take for humanity to finally close the loop on malaria forever?